Hi, and welcome to my video on color management. To get started with color management, I'd just like to recall the two types of color models that there are. We've got the pigment model, the CMYK, that we learned in kindergarten, that shows physical pigments reflecting color. And then we have the light color model of RGB, which is anything that has projected light. Phones, tablets, projectors, monitors, TVs, etc. They use a different color model. And color management is about translating between RGB to CMYK and getting the colors to match when we can. So it's just something to keep in mind that we're dealing with light and the physics of light. And speaking of the physics of light, there's a lot of science that has gone into how we perceive color. So there's a lot of variables that change how we perceive colors, and I'm sure you've seen color illusions, but that's something to keep in mind, is that when you are viewing color, what is the environment that you're viewing that color in, or where is that color placed next to other colors, because that'll affect how you see light or color. So for instance, these blue stars here are the same color blue, but they look different because of the surrounding color. And the same goes with these gray stars here. They're the same value of gray for these three and for these three, but they look different because of the colors that are around them. So when it comes to color, we need to think about the type of viewing area we're in. So like when we're in the lab, there's a lot of fluorescent light going on, but if you're at home, you might be just surrounded by incandescent light, which is a different light. The color of the light is different. Also, if you're using or if you're viewing something that has mixed lighting, like outdoor lighting and indoor lighting, that's just something to keep in mind. But we're going to move on and look a little bit closer at colors. One concept to understand is color gamut. That's G-A-M-U-T. And color gamut is basically a range of colors that a device can project or see or read. So like our eye can see a certain number of colors. Your monitor can display a certain number of colors. CMYK can only print a certain number of colors. So that amount of color is called a gamut. And every device has a color gamut. So that's the range of colors that it can produce. Currently, our eye has the biggest color gamut, the visible light spectrum. And then as you can see in this diagram here, there's color film is a reduced set of what we can see with our eye. Your monitor is even less colors than what you can see on color film. Printed paper, coated paper is less than that, and newsprint is even less. So part of the color management issue is what do you do with those colors that you can't translate into the printed medium? One main key aspect here that I'd like you to know is that RGB has a wider range of color than CMYK. So when you're looking at your monitor and you're designing, many of those colors will not print because they can't be mixed down into the CMYK inks. So that's where color management comes into play, and some of those colors have to be translated into CMYK. You lose brilliance, you lose some of the color range. That's right, there's a diagram down here. There is a 6-color printing model, which adds, instead of CMYK, you add green and orange inks, and that can expand the range of printing. However, it's pretty expensive and it's pretty rare. And it's different to, the pre-press departments have to have the software to be able to process and print out, a green plate and an orange plate in addition to cyan, magenta, yellow, and black. So I haven't seen any in Bellingham, but it is possible, and that can give you more range of colors. So to describe color management, I've got this analogy that I've used with toast. And so bear with me here, but It's not a perfect analogy, but it might get the idea across to you. So imagine you got 3 toasters, and they're all different brands, and you set all the toasters to a brownness of 7, because you like your toast just perfectly browned. So you set it to 7 on each of the toasters, and lo and behold, toaster 1, the toast comes out like this. Toaster 2 comes out darker, really dark, and toaster 3 comes out darker, but not as dark as toaster 2. So even though they were all set at the same brownness color, they come out different. And that's obviously because they're different toasters. So what happens is that if you imagine the toasters as your input device, say toaster 1 is a camera, and toaster 2 is a scanner, and toaster 3 is an Illustrator file that you just created from scratch, they're going to produce colors differently because the input of where those colors are coming from are slightly different. So color management tries to correct that, and it says, okay, well, we want this desired outcome of this nicely browned toast, so we'll leave toaster 1 at 7. We have to adjust toaster 2 down to a setting of 4, and we have to adjust toaster 3 to a setting of 6 to make the toast come out the same. So color management is the process of adjusting those settings to come out with the desired outcome that we want. So the way that works, the way color management works, is through using and manipulating color profiles. So if you think of a color profile as being the setting number on the toaster, then that might help. The color management system would take the setting for toaster 2, the setting of 7, the profile, and it would convert that profile to the output of what we want, which is a nice brown toast. So the management system has the rules, which is output this to my monitor, or output this to CMYK offset printing, or output this to a LaserJet printer, or output this, so the color management system has the rule of where it's outputting it to. The input is the color profiles from what was given to it from the images and the designs, and it has to translate those profiles so you get the correct output. Color management uses color profiles to convert colors for the device being used. So what is a color profile? Here is some images that show the color gamuts again. Image A is the eye, and then we've got RGB, CMYK. They're different than the other images I was showing you. They're just rough estimates. But a profile is anything that sees color. A color profile is the mathematical description of how a device sees color, whether it's an input device, such as a camera, scanner, or an output device, such as a monitor or printer. So even monitors have profiles, printers have profiles, presses have profiles, scanners have profiles, cameras have profiles, and so on. So every time a image is created, either through a camera or scanner or through your Adobe applications, a profile is assigned to it, and that profile tells the color management system what colors it sees and its mathematical formulas for making those colors, because they are different. Nikon is different than other camera manufacturers. I just blanked on the camera names. And different monitors have different manufacturers, and they use different profiles to generate the colors that they make. So you can see that each device has its own profile, and they range in the amount of colors that they can display. So to kind of show how that might work, here's a simplified color management process. I got a digital camera. I go take a picture of an apple. That apple has a profile assigned to it from the camera. So I want to send that image to my monitor. And so the color management system says, hey, this is going to go to this monitor, which is a Samsung whatever monitor. And that Samsung monitor has a profile to display colors. So the color management system takes the input profile from the camera and the output profile from the monitor and aligns the colors so that they see correctly, or that they show the same colors correctly. But sometimes, like say the camera might have a wider gamut of colors than the monitor, and the monitor has a smaller gamut of colors. So what happens to those colors that come from the camera when you're putting it onto the monitor? Well, those colors have to be translated into other colors, and you might lose some data, or colors might shift a little bit, and so on. And then that same camera image, that same photo of the apple, I see it on my monitor, and then I decide to send it to the printer. Well, the printer has a profile, and the color management system has to match up the Apple photo profile with the printer profile, and then be able to match the colors and have them print correctly. So there can be mismatches between colors from different profiles and the translations, especially when you're going from RGB to CMYK. So that's kind of a simplified version of what color management is. There is a lot of in-depth study you can do on color management, how the profiles determine what the colors look like through math. That's well beyond my skill set. But some of the key points here is that you should be using color management, and you should turn it on and be aware of what's happening